Hi, everyone. Welcome to our final keynote for the day. Before we get started, I want to thank Microsoft for sponsoring this session. This session is called Discovery in Action Through Geospatial Visualization and Urban Analytics. I'd like to introduce two of my favorite people, Farès El-Dahdah. He's a professor of art history and founder of the Spatial Labs here at Rice. Katherine Ensor, she's the Noah G. Harding Professor of Statistics, Director of the Center for Computational Finance and Economic Systems, and Director of the Kinder Institute's Urban Data Platform, and also she happens to be the President of the American Statistical Association. Thank you guys for being here. I'm looking forward to your talk.
Thank you. All right, hello everyone. Let me see how to do this. Unfortunately, I only see my stuff. I don't see anyone, but I'm presuming everyone is there and I'm not talking into a void. Regardless, it's a pleasure to be here. Thank you, Angela, for the introduction. And off we go. So what I will present today is basically a capability that we currently have here at Rice in the area of data visualization and in the form of the Spatial Studies Lab. It will all lead to an ongoing collaboration with Dr. Ensor, from whom you will hear in the second part of the talk. So first of all, the Spatial Studies Lab basically consists of a group of researchers, GIS specialists, designers, many interns, and developers, all working together to build online geospatial platforms. We basically combine vector, raster, and other forms of data at the intersection of time and space in order to create web experiences and in the hope of allowing others to pose research questions of their own. In terms of how we work, we basically take raw data, we gather it, curate it, standardize it, catalog it, and analyze it. Then we give this data form by synchronizing, formatting, and stylizing it. Only then we code a project by developing it and finally deploying it. The fields of research where our projects operate include cultural heritage, climate change, public health, disaster response, social justice, and even digital tourism. Here are a few of our ongoing supporters, a sample of the technologies we use, and the research clusters where our projects have tended to coalesce. So the story of this capability begins, in fact, long ago, about a decade ago, with a project on Rio de Janeiro that got us going. More specifically, it began on a placemat at the faculty club when my colleague, Professor Alida Metcalf, and I thought it would be a good idea to work together based on what we then knew about Brazil. We listed topics that we could investigate while knowing literally nothing about data and databases. So we then felt the need to situate the material we had collected in a temporally accurate environment, and with the help of the university's GIS data center, we somehow transitioned from what was no more than an image repository to what became an illustrated and geographically informed system. Since we really had no clue how to visualize our data chronotopically, by that I mean in time and in space, we turned to Axis Maps, a digital cartography studio that helped us get things started and with whom we continue to collaborate periodically. Our project then became known as Imagine Rio, which was the data version of what was first imagined on a placemat. And by that I mean a searchable map that illustrates the urban evolution of a city over its entire history. Not only as it once existed, but also as it has often been imagined, since that too can be located in time and in space, in terms of when it was created. So in this Imagine Rio, views of the city, historic maps of the city, as well as site plans by architects for projects in the city are all geolocated in both time and in space. And I'm going to show you what that looks like. So this is actually, I will show you first version number 2 of the project, and then show you the more complicated version number 3. So this is a map of Rio. We are now in 1565. There is a timeline at the top. You can move year by year. Now we're moving in 50-year increments. And you can see how the city changes, not only in terms of its road infrastructure, but also in terms of its coastline. That changes accordingly. Here we go. And then once you get to the present, you get the most recent satellite image. So in this map, we can locate views, drawings by architects, as well as locate their cones of vision. And then once they are selected, one can inspect them more closely. We can also situate historic maps, zoom in, and these are essentially the references upon which we built the map ourselves, and their transparency can be changed. And then there are also plans by architects, so futuristic plans or actual plans, either way. We can locate them the year they were created. And one can also go and inspect the document itself, which sits in its own image repository. Of course, the map has a map legend, and this map legend can be selected. In other words, one can filter the parks. What's next? And then one can explore by area, meaning draw a polygon on the map and collect all the information that falls within that polygon, and then click on these features that are collected, and they highlight in the map. So in this version 2, we also added plans by the municipality of Rio that looked ahead, and the city will eventually grow into these plans. All right, moving right along. So over a period of few years, ideas that were first jotted on a placemat somehow transformed it in what one would today call a geostack that looks like this. It consists of a geographic information system, in other words, the GIS environment where we do most of the work and where we keep our vector data, an image repository for all our raster data, a very large storage drive on campus, thank you IT. Then there is a relational database that hosts the Node application, which integrates our various data types. And all that is then integrated somehow into a delivery web system and service made of a manual of style, a map renderer, storage space in the cloud, and an API to request metadata and data across the entire database. And finally, the user interface. So this is actually no longer the case, but that's how we built the original map. So we were coincidentally working on making the map render on one's computer rather than render on a server and then deliver little raster tiles. So we created this test, which was how to, oops, it has, sorry. Forgive the music, but it's kind of cool. So this was an attempt to make the map render on one's computer rather than render on a server, and that way the changes between years would be far more seamless. And this was a preamble to version number 2. This was done for effect. Okay, moving right along. So then we got a grant. So with the support of the Getty Foundation, they had this grant in digital art history. And in partnership with an amazing photography collection in Rio called the Instituto Moreira Salles, our goals now got a bit more ambitious, and now they consist of ingesting 4,000 public domain images from the Moreira Salles collection while locating them in both time and space. And we are also committed to making this platform triple IF compliant, and if you'd like, I can explain that later, in order to basically allow others to use our images, and so that we could eventually use other people's images as well. All our codes and geographic database are published under open licenses, and our data is in the process of being mirrored on Wikidata. So these are our new set of goals, which are a bit more ambitious. So one of them, so along with these goals, we are running these experiments around this data set, which include a partnership with a platform called Snapshot, which allows for crowdsourcing the geolocation of images and the retrieval of very accurate viewsheds. So basically, one looks for control points between the photograph and a digital elevational model, and then that situates the historic photograph in space. I'm not going to wait for it to end, so here we go. Another experiment we're running is with a team of researchers at the School of Applied Mathematics in Rio at the Fundação Getúlio Vargas, and where we're also developing a prototype for mono-camera calibration and dimension extension, meaning for buildings that no longer exist, we would like to get their dimensions from historic photographs and therefore situate them in our cartographic platform. The latest version of Imagine Rio also has a narratives or storytelling component, so that any researcher can do the equivalent of a PowerPoint presentation directly linked to our map, and therefore have this New York Times article effect. But the map in the background is actually live, and if it gets updated, the PowerPoint updates accordingly, or at least the narrative updates. So this leads us to the latest version of Imagine Rio, and it looks like this. Essentially now it consists of the same timeline above, but now it has an Airbnb effect, meaning the map and the set of photographs that are supposed to appear here, I don't know why they're not appearing in the video, they should be there, are now equivalent. So you move the map around, the photographs select and reselect. So these are all the photographs we now have. The timeline cursors are now more complicated. The outer ones are for the images, the inner one is for the map. And then it works much the same way for the previous one. But in essence, one can also search by polygon. But this pane here can be enlarged so that one either looks at the map or either looks at the photographs. Here we go. And so one can do temporal searches in photographs as well as the same way one can do it with the map itself. Each point has a view cone, which will eventually be replaced by a view shed, an accurate view shed that we will have collected from Snapshot. And then now we can tilt the map to correspond to the photograph. And then we have far greater zooming capability for these high resolution photographs so that one can inspect them in great detail. All right. So in order to make all this work, the GeoStack has now gotten way more complicated, but it does allow us to create other such chronotopic projects. It shows all the components that make up that now make up the Imagine Rio platform, and in essence, we've gone, how to say, we are no longer relying on a big brain. We are relying on microservices that are all small, reusable, extensible, and open source components. There is less risk, which means if one of them is down, the map continues to work, which means the whole project is built to fail gracefully. It's all file directories that are static. There is technically no maintenance mode. It is in no maintenance mode, in other words, and each piece can be used by other applications. So early on, and in order to convince the university to support IT infrastructure for us, for such projects, we came up with the idea of this little project, which was to do essentially the same thing, and we're still working on it for the Rice campus, and it works on one's phone, much as Imaginary actually one does. It essentially situates you in a historic map so that you can see what you would have seen had you been there way back when. So all along, Kathy kept saying that we ought to do the same for Houston. And this became imperative when Hurricane Harvey happened in 2017. So the same mapping capability that we had, we now could apply to Houston. After all, people should know that they built their houses in what were once rice fields. So here we go. So now we are working on a similar version of a sort of diachronic map, but this time for Houston. And for the sake of, so essentially you see the city growing, and it works much the same way the Imagine Rio platform works. With one big difference, we can now add thematic layers that will show things other than geographic features, social vulnerability among them. Here we go. So for example, if one wants to look at the CDC's social vulnerability index, we can bring it up. It is temporal as well. It changes over time. And then, like every map, things can be filtered by type. For the sake of time, I'm going to move ahead. So while these maps, the data is year by year, for the Houston map, we thought it would help if we did it day by day, and you'll understand why. So if one goes back to August 2017, August 27 or so, and then for the next 5 days, the city got flooded entirely because of Harvey. And since we could technically reconstruct that flood, now the Houston map will have its temporal accuracy down to the day. In order to map out all the buildings in Houston that came and went, we are relying on old insurance maps, and there are many. They are fed in a deep learning model, which allows us to literally harvest building footprints. So basically, a computer recognizes colors and shapes and gives us back vector data that we can then upload in the platform. Then the pandemic started. So we had the idea of using our skills and technologies to create and deliver interactive dashboards that visualize the evolution of COVID-19 in various cities, in states, and in countries. We started with Brazil, which is the country about which we knew the most. We did it by state and by city. It went completely viral and was even on display at the COVID-19 Crisis Command Center of Brazil's Ministry of Science, Technology, and Innovation. It received unexpected press coverage. Even the governor of São Paulo uses our dashboard as a kind of meaningful background for his social media videos. And then I had no clue that when I first got involved in all this, I'd somehow be in the business of harvesting data in a moment of crisis and making it visually and publicly accessible. So a large explosion happens in Beirut, and my team and I felt compelled that yet again, we needed to build something that could be useful in time of great need for anyone in need of a particular set of information. So this project next illustrates how the web can serve to produce useful tools in a fairly in fairly rapid speed. So this is a map of the damage in Beirut on August 4th, 2020. We could produce this map fairly quickly by comparing satellite photos. We had all the building footprints of the city, and the Red Cross had come up with its own zones for NGOs to work in. So that way, someone working on Zone 11 could go there quickly. And in order to inspect the damage, even from a distance, we harvested people's photographs that were being uploaded to a public platform called Mapillary. And that way, even on one's phone, one could fairly quickly have a sense of the damage, where and when. And then there these photographs come in two modes, either this panoramic mode, and this was done in lightning speed by just harvesting what we could get our hands on the web itself. And then we could also, either based on our own assessment, which was from a really far away, we could filter buildings by damage, but then we could figure out, since we had the date of their construction, we could compare that with their building code to see what kind of seismic code they abided to, and that way we could assess whether they were severely damaged or not, and things like that. So, and if you click on a building, you can find out what parcel and how it is being represented. And the idea was to monitor the recovery of the city little by little, by then asking those who were doing actual surveys to give us their information so that we would visualize it for them. And so we worked with various groups who gave us their surveys, and then we could visualize it for them and for their own use. And finally, we not only geolocated surveys, photographs harvested on the web or given to us in terms of surveys by local organizations. Not only we could make comparisons between before and after the explosion, but we could also geolocate videos of either the explosion itself or the aftermath of the explosion. And to do that, we created an avatar for videos, so that what you see in a video, you could click on in the equivalent 3D model and get some information. So if you want to know what this building is, you can click on it, and it will give you whatever information we could get our hands on. And finally, in order not to take too long, so speaking of data visualization expertise in the middle of a crisis, Kathy invited my team and I to help her build a dashboard that could best represent the statistical analyses that she and her collaborators were painstakingly performing. So this is where we are now collaborating closely. And this is, so I will ask Kathy to comment on this latest collaboration of ours. Kathy?
Thank you, Farès. I'm always so amazed every time I see you talk about this. It's just so impressive. Okay, so we are looking at a video of the dashboard for the COVID wastewater analysis that's being done for the city of Houston. And we thought this was a good topic to bring forward because you actually saw it last year with Dr. Stadler highlighting this program. And so on this dashboard, you can see this is a footprint of like a school, for example, and you can see exactly what's going on within that school. and there's heat maps that display the temporal information along with all of the different places where things are measured. And so then there's also a citywide look where the information on the wastewater treatment plants is portrayed, and whether it's increasing or decreasing. And I'll go into the details of this a little bit in my talk, but this site is publicly available, and we hope that you do explore it. We do provide information at the zip code level as well, and everything is relative to what happened on July 6th. Again, I'll go into a few details in my slides. But you can understand the trends across these wastewater treatment plants, and so you see the peaks that we're in. And there's also information on the variance that is included on the dashboard. And so we're really sort of sharing all of the science that we have with the public through this dashboard. And the Spatial Studies Lab team has just done a phenomenal job at bringing this forward. So I think now we can switch to my slides. Farès, is that right? So,
yes, correct.
Okay. All right, thank you. Okay, so let me, whoops, I'm kind of not at the beginning here. All right, let me go to full screen just a second. Okay, so what I'm going to try to do is talk to you about the data, the analytics behind the message, and a few points on data stewardship. So I call this engineering a statistical solution, and I spend a lot of time in this space in general. And it's really a partnership between local government and academia for the purpose of an impact. And with SARS CoV-2, we did really stand up a system for wastewater epidemiology for the city of Houston. We conducted a specific study to understand the prevalence of SARS CoV-2 in Houston, and then I'm going to give some indication of how I can link these two things together. And each of these has an immediate impact. So wastewater surveillance, again, my job was turning all of these measurements into actionable information, and that's what I'll be talking to you about mostly today. But remember that this is a team, and Dr. Hopkins is sort of the brave leader of the overall team, and she has a joint appointment between the City of Houston and Rice University, and really leads these innovations. Dr. Stadler is that brainchild behind wastewater epidemiology, and Rice and Houston are just so fortunate to have her as part of the Rice faculty. And then early on, or well, for the first year of the project, the Taylor Lab at Baylor was integrally involved in helping us develop these methodologies and this design. So what happens? So there's actually, data that's collected, and that's sort of the message that I want to bring forward today, is that, there's this real kind of granular information of which comes into this system that we built. We get some analyses out, but then after we've done all these analyses, then there's action by the health department, direct action by the health department in terms of helping our community really do the best we can through this really critical pandemic. So here's a static map of what's so beautifully displayed on Farès's dashboard, and so this displays all the places that we're actually sampling. And so these large regions that are different colors are actually the wastewater treatment plants for our region. You see the purple is 69th Street, and it serves 500,000 people. There's smaller ones that may only serve like 5,000 people. So there's really a large disparity in the service district for each of these. And then each of these dots are also individual pieces of information, again, that you can see on on the dashboard, and we're testing at schools, at nursing homes, at shelters, at lift stations, at jails, and then we do try to take all the information to the zip code level, because that's the actionable public health unit for the health department. So this is a semi-automated process, and I just threw up all the different tools that we're using, and so definitely, Excel has a leading role in terms of bringing the data together, and this is small data. This is not big data, and so that's fine path. From the analysis side, R plus R Studio and Python, and then the health department relies on SAS extensively, and so we have to be able to integrate there as well. And then everything is fed into GIS finally to create the maps and do some additional analytics, and as well as the dashboard. I'm going to kind of skip through this. You can explore I encourage you to explore the dashboard, but one of the main pieces of information comes from this very extensive sampling of the wastewater treatment plants. So they've been sampled weekly since May of 2020, and so we really have a lot of information. And the idea is that, okay, so the samples are collected, are taken on Monday, delivered to the labs on Tuesday. The data is available Friday morning. Preliminary reports are available Friday afternoon. The summary report will be delivered by Monday to all of the decision makers within the city. And then the public website is updated on Monday as well. And that's the dashboard. And these are current plots, and so we see that we're at 129% of our benchmark level, which is July 6th, and so we're about out of that second phase. I'm going to skip some of these details, but step 0 is our data and sampling issues, and because wastewater epidemiology is becoming so pervasive around the world, because it's very, very useful, I do want to remind everybody that this is very messy data. So there's a lot of measurement error, there's a lot of sampling error. There will be missing data. For example, if it rains heavily, then we're not going to collect. And then the replicates that we're dealing with are technical replicates. So we don't have duplicate samples, but technical replicates. So they measure the lab variability and the inter and intra-lab variability. Another big statistical issue is, how do you normalize across such different size sewer sheds and lift stations? And so here is our sort of raw analysis that I call step 1. And so these plots are very messy, and they're only for the analyst in the background. So the public would never see these. The decision makers in the city would never see these. But these are the raw plots that tell us what's going on with every single observation that was taken. And so, for example, every observation with a circle around it means that there was a non-detect in that measurement. And so how do we deal with that? And so what do we do? And you notice that the change in over the time course is highly non-stationary, and this is the change that we're trying to pick up. And so what we've chosen to do is we do model this with basically a natural spline for the temporal profile, including temporal dependence as we're bringing in these splines. And so there's a lot of sensitivity check. We first do an analytical sensitivity check, and then we actually plot all of these curves, and we look at them very seriously with different parameters before we make a decision each week, paying particular attention to the endpoints. And so then we put it all together. So this is the sort of rolling it up to the analysis step 2. And so that top curve is our best estimate of the wastewater viral load for the city. And you can see that it starts July 2020 and ends November 2020. Well, it's current. It ends with with October 18th. So this is actually the current information. And the reason that we start at the beginning of July is that's when we really feel like our data and our processes really sort of came into play. And so this is the time course over each of those wastewater treatment plants. And then we start communicating the results. And so we're going to compare this as a total for the city. And again, you can see this on the dashboard, but the bottom curve are the PCR rates, positivity rates. And again, the top curve is the wastewater. And you can see that there's strong coherence between the two. In fact, through a separate analysis, we can actually estimate the prevalence rate as well as forecast the prevalence rate a couple of weeks out. And I won't go into the details of this analysis, but if you actually look at the blue curve here on the right, that is generated totally from wastewater and has nothing to do with positivity rate or the prevalence. And so you can see that we're tracking extremely well. We do have overlaid the positivity rate, and so it is tracking very, very well. And so we have strong ability to estimate the prevalence as well as forecast the prevalence based on wastewater. So wastewater epidemiology, it's scientifically sound and robust. You do need to understand the complexity. You can build semi-automated systems. I'm not sure that we could fully automate it, but the information is actionable. So I want to move to the second study, just a couple slides on this. I'm really cognizant of the time, but this is, we did take on an estimate. We wanted to understand the prevalence of SARS CoV-2 in Houston. And the goal was to guide policies and actions. And so the city of Houston and actually also the county has a similar analysis, but the city of Houston, we piloted this with the city of Houston, and so we decided. So this was done in September of 2020, and so we're actually going to go into homes and ask people to allow us to draw blood to actually check for whether they have antibodies for SARS-CoV-2. And so this is a very highly designed sampling effort for the city. And so we divided the city into two strata, one where the positivity, we call it the low strata, where the positivity rate was lower, and then the high strata where the positivity rate was higher. And again, this is September of 2020, because we really did not have a good sense of what actually was the prevalence within the city. And so you can, it's even notable to understand sort of the low and the high. And so then within the each strata, we randomly selected 30 census block groups. And then within each of those, we randomly selected 7 households. And then within a household, all individuals within a household were invited to participate. All individuals 5 and older were invited to participate. So we obtained information on 678 residents living in 428 households. And so, but since this was a design study, we understand the population characteristics, we understand the probability of inclusion in the sample, and so we can do our full statistical analysis on this information. And so what we found at that time is that roughly 13.5% of individuals living in Houston were infected with SARS CoV-2, or roughly 250,000 people. In the high strata, this was 18%, in the low strata, 10%. And the intervals are the 95% confidence intervals associated with these point estimates. So the takeaway was the prevalence was more than a factor of 4 of the PCR nasal clinical case counts. And it was the factor was actually 4.6 in the high strata and 4.3 in the low strata. So this truly gave sort of the public health officials in Houston a true understanding of what was going on within the city. And then findings are broken down by age, gender, race, and ethnicity. And we do have a published paper on this result. So there were two, again, so if we take both of these, so if we wanted to understand the extent of the pandemic on Houston, that's where the very scientific, detailed seroprevalence study came into play. And again, we learned that 250,000 people were infected in September 2020. The prevalence was greater for women than for men, for young than old, and differs across racial and ethnic groups. And again, the details of that can be found in our paper. And then when we talk about managing the community spread, that's where the wastewater really comes into play, because we get this spatial temporal evolution of what's going on. And the city actually acts on this information, sending out strike teams to neighborhoods, to schools, to congregate living facilities. It's just so impressive, the effort that our health departments in our region have gone to help us. So moving away from just kind of stepping back a little bit into the role of bigger picture of urban analytics and the important role of statistics, data science, and AI, I just want to point the audience to a few things. So there was a National Academies workshop and follow-up information on urban sustainability that really made use of the types of things that I and Farès are talking to you about today. And then I want to give a shout out to both Rice and the Houston area for this strong partnership between academia and the universities, and not just Rice, all of the universities in Houston. That's just, I happen to be at Rice, but it's really this strong partnership between universities and local governments really is significant. And then at Rice, we do have the Kinder Institute for Urban Research, and then the Urban Data Platform that I've headed up for the last few years. And so just a couple of pointers there. Again, I really invite you to look at the Kinder Institute if you're not already aware of it. And for the UDP, so the idea of so go to kinderudp.org. This is curated, research-ready geo and time reference data with the idea that the more information that we can get cataloged about Houston, the more important the questions are that you can answer. And the data is actually published, which means it has a DOI and gives it some permanency. So why can we have an impact? Our willingness to engage, to answer questions now and not 2 years from now. Our willingness to incorporate core research, and then maybe hold off a little bit on writing some of those papers. We're building on strength of long-term collaborations. Definitely the infrastructure at Rice and other research institutions in Houston as well. But again, a shout out to the Kinder Urban Data Platform. But these are here, ready to go and in the right direction. And then the university supports this type of idea, both financially, but also in recognition of its importance. And so this just, so that has to be part of the equation. And in general, what we do really matters. And for that, I'll thank you. And then here are the links to the actual websites. So the COVID wastewater treatment plant spatial studies lab, so that'll get you to the dashboard. Spatial studies lab in general, Farès's efforts are just phenomenal. I just really encourage you to spend an afternoon exploring the spatial studies lab, and then this great data resource, the Kinder UDP. And with that, I will stop.
Thank you guys so much. I don't know if you've seen the comments, but people really liked it. But one thing I was going to say, okay, because you talked about something actionable, and the water treatment dashboard is how I decided like the conference had to go virtual, like and I did. I could see it like 6 weeks ahead. Like, yep, gotta do it. So it helped a lot of people, including me. I just wanted to say. For the water treatment plant project, one of the questions that always comes up is there anything about data privacy? Are there any concerns about data privacy associated with this level of detail when we're using the water treatment?
There really isn't. I know that it feels invasive, but it really is community level information. Even at the school level, you think about everybody at the school who's making use of the facilities, and so it really is, general public information. It isn't getting to any individual or any groups of individuals, and but it is a great resource for understanding what's going on in the community.
It's an average of a lot of things.
Literally, yes.
Yeah, literally. I feel like I messed this when you were talking about. You were able to pick apart some of the demographics, the demographics that lean towards having COVID more than others. How did you do that with that level of detail?
Okay, so that was the seroprevalence study. And so it's separate from the wastewater.
Okay.
So that was a separate study that I collaborated with the city of Houston. And we went into people's homes and we asked them to share their blood, and the blood was tested for the antibodies. So this was a designed experiment with only 680 something people. And thank you for those people for participating. But they were randomly selected. So it's also evidence of the value of randomly selecting. I can get a lot of information out of 680 well-designed sample points, and that's what these were. And so since we know the people and they agreed to participate in the study, we know their race, gender, age, etc. And then we just link that to population level information.
Farès, you have this wonderful platform. Like, are you always looking for more collaboration? Should people reach out to you?
You're on mute, Farès.
So yes,
Or Kathy's going to keep bugging him.
The more the merrier. No, because mostly it all started in urban history, in a completely humanities environment, and suddenly crisis, disaster response has become something, in which we've developed some kind of expertise. So totally, that was never in the cards. I mean, it somehow happened because of a series of disasters, beginning with Harvey, the explosion in Beirut, and the pandemic. So yes, we've collaborated with enough groups across campus, even, and we would be happy to collaborate with others. And the promising relationship is this one between Kathy and I.
We're certainly having a lot of fun.
And it was Kathy, by the way. I realized this while preparing this. Kathy, after seeing the Imagine Rio project, Kathy kept saying, "You need to do one for Houston." And I was like, yeah, we will one day. And then Harvey happened, and then I realized, what am I doing? It's totally imperative that we do it for Houston.
Yeah, and I think that's part of the message, is because if you think of, we all often say Houston as our laboratory, everything that goes on here. And so this is a wonderful place to research and to learn about our own community. And our history is relatively recent, so you don't have to go back too far. So.
Farès, do you have a plan to make your platform available so that people can build their own metaverse universes?
So yes, we're working on another project. attached to we did sort of the same thing for Beirut and it was that data that allowed us to do the explosion map. There we will, if all goes well, we will be making available our workflows in sort of user-friendly interfaces so that people can build their own temporally accurate maps connected to images, views of the city, maps of the city, plans of the city. But that we're working on now, thanks to a grant from the New Levant initiative. And so it's catered for the Middle East, but once we figure it out, we will then open it up for others. I need a few more months for that one.
Got it. Okay, so I want to repeat what Kathy said. Everybody should go look at the Kinder Institute's website. What they do is amazing. It's great work. One of the things that Kathy has done is the urban data platform. I don't know if you had a chance to mention it, but there's like 200 data sets there that get used by like 700 people a year. I mean, what would you tell people about what kind of data sets they are quickly, that maybe tell them, and how can they use them if they want to?
Yeah, so the Urban Data Platform is designed for everyone to use. And so if we obtain the data if it's publicly available data that we are allowed to share, we make our improvements on it and then we publish those improvements. You just have to become a member of the UDP, so you just have to register so that we know who you are, and then you can download the data. But just as important is some of the more secure data that we have associated with the UDP, and that, of course, is not available to everyone. But there are procedures if you're doing research and that you can get access to this data for it's not easy, nor should it be, because it's very confidential information. But everything is geocoded and time-stamped, and so it's very easy to integrate. I think we're up to actually almost 250 data sets, and all the data that you can think that you would want. Our goal is that it will be published through the UDP. And again, once we publish it to the UDP, then it's permanent. So it's not going to go away if somebody's website goes down. It's going to be there for your use. And does that help, I guess?
That's great. Thank you. Thank you guys so much for speaking. It was great. See you guys again, as always. I guess this is this starts again tomorrow at 10 a.m. We have, about 15 technical talks, basically covering a lot of the latest research going on here in Houston. And I want a reminder to everybody who we have a open reception at 4:30 I guess it's called Holman Bar in Midtown Houston. So if anybody can make it, please feel free to join us. Holman